Hey everybody, welcome to Geometry, Section 5.2, Perpendicular and Angle Bisectors in Triangles. By the end of this lesson, you should be able to understand the vocabulary associated with angle bisectors and perpendicular bisectors in triangles. You need to be able to create and know the significance of the incenter and the circumcenter. You should also be able to use diagrams of angle and perpendicular bisectors in triangles to find missing values. So let's hop right into some vocabulary. So first word you need to know is the word concurrent. All that means is that you got three or more lines that all meet at the same point. So we can see here we've got line A, line B, line C. They all meet at one point. So we would say that those three lines are concurrent. Now the point where they meet is called the point of concurrency. So I would say point E is the point of concurrency. And we're going to deal with two specific kinds of points of concurrency in this lesson. The first one of those is called the circumcenter. And all that is if you have a triangle and you do all three perpendicular bisectors, those three perpendicular bisectors will meet at a single point, and we call that point the circumcenter. And I'll tell you why we do that in just a little bit. And the other kind of point of concurrency that we deal with is called the incenter. And that's where if you do the angle bisector of all three angles in the triangle, they'll all meet at one point, and that point is called the incenter. So let's go ahead and create the circumcenter. So here I have just a regular triangle, nothing special about it. Okay, I'm going to go ahead and do the perpendicular bisector of all three sides. So obviously those two intersect. When I do the third one, it's going to intersect at the exact same point. And so that point is called the circumcenter. Now, as we move that triangle around, you can see that right now the circumcenter is inside the triangle. But if I were to make this an obtuse triangle, you would see that that incenter, or the circumcenter, is outside. All right, let's try again. Okay, there we go. When it's an obtuse triangle, the circumcenter is outside the triangle. If I make it an acute triangle, then the circumcenter is on the inside of the triangle. And if I were to make this a right triangle, the circumcenter would be right on one of the sides. Okay? So, why do we even study the circumcenter? What's the importance of it? Well, I'll show you. All right, here's why we study a circumcenter. Okay, if I take that point and then one of the vertices, and I make a circle, notice that that circle hits all three vertices. And no matter where I move this triangle, that circle stays on all three vertices. So the significance of that is that this circumcenter is the same distance from all three of those points. Okay? So for instance, if you're a city planner and you have three significant points in the city and you want to create something that's the same distance from all three of those points, you would need to find the circumcenter, and that's where you would put your new landmark. Okay? So let's go ahead and do some notes on this. All right, so back to the notes. Let's go ahead and fill in some of this vocabulary, which we've already covered. It says three or more lines that intersect at one point are called concurrent. The point where they meet is called the point of concurrency. And the point of concurrency for perpendicular bisectors is called the circumcenter. And the circumcenter of a triangle is the center of the circumcircle. So the point where they all meet is called the circumcenter, and then the circle that you make is called the circumcircle. Okay? And if you know anything about Latin and Greek derivatives, the prefix circum means around. So if Magellan circumnavigated the globe, that means he sailed all around the globe. So it's called the circumcenter because that circle goes all the way around the triangle. So as we pointed out in the video, that if you have the circumcenter, then that is equidistant from all 3 points. So MN is the same distance as MP is the same distance as MQ, no matter how you do the circle. And as we said in the dynamic illustration, if it's acute, the circumcenter is inside the triangle. If it's a right triangle, it's directly on the triangle. And if it's an obtuse triangle, that circumcenter is outside the circle. So here's a diagram. Let's go ahead and fill in the blanks here. So let's take a look at the clues. It says DH, DG, DH, DJ, and DK are all perpendicular bisectors. So that tells me that point D is the circumcenter. So if I want to figure out how long DG is, so from that point out to a vertex, well, that's going to be the same as from that point to any other vertex. So since DF is 19, that means DG is also 19. If I want to know how long EK is, well, the trick here is that because they are perpendicular bisectors and GK is 17, that means EK also has to be 17. FJ, since GJ is 15, that means FJ has to be 15. And DE, well, since DF is 19, DE also has to be 19. So you'll see quite a few diagrams like that, where you have to recognize that from the circumcenter to each vertex is the exact same length. And also, because they're perpendicular bisectors, if you've got a side, this half is the same as that half. So those are the main things you need to know when you're filling out a diagram. Now let's talk about how to graph a perpendicular bisector and create the circumcenter. So here on this graph, I have a right angle or right triangle, which is important because this is going to be a lot easier than if it wasn't a right triangle. Also, one of the lines is perfectly vertical and the other one's perfectly horizontal. That makes it so much easier to do. Because here's what I'm going to do. I'm going to go to my vertical side. It goes up 6 spots. So to bisect it, I only need to go up 3. And then just draw a horizontal line through that. Let me do that again with a thicker line. Okay, so that green line is my perpendicular bisector. I'm going to do the same thing down here. Looks like it goes over 1, 2, 3, 4. It goes over 4 spots. So I go right in the middle and then make a vertical line. Now I could go ahead and do the third side, but I know it's going to intersect at the exact same spot. So all I have to do now is take a look at where those 2 lines cross. Looks like they cross at 2, 3. So that is my circumcenter. Easy enough. Let's do another one. Let's get a different shade. Let's go with pink. So I'll do the same thing over here. One side is perfectly horizontal, one side is perfectly vertical. Makes it nice and easy. So looks like this side is 5, 6, 7, 8 units long. So I'll go over 4 and make a vertical line. Do the same thing over here. Looks like it goes up 5, so I'll go up 2.5 and make a horizontal line. And then the point where they meet, that's my circumcenter. So it looks like I went backwards 4, and up 2.5. And there's my circumcenter. Okay? Now get to know how to do that because you're going to see that on tests and quizzes. Now let's go ahead and move on to the incenter and the incircle. So here I have another triangle, and I'm going to create the angle bisector for all three of these angles. So there's one angle bisector. There's another one. And I bet if I make a third one, it's going to cross at the exact same place as the other two. And sure enough, it does. So let's move this around and see what happens. I can make it an acute triangle. I can make it an obtuse triangle. I can even make it a right triangle. And no matter which way I do it, the incenter is always inside the circle. Okay? So no matter what, the incenter is inside the circle. So let me show you the significance of the incenter. First thing I'm going to do is I'm going to make a perpendicular line. And then where that perpendicular line meets that side, I'm going to create a point and then create a circle. The reason it's a perpendicular line is because distances are always measured through perpendicular lines. Now, notice what magical thing just happened here. That circle fits perfectly inside that triangle. And no matter where I move this triangle, that circle will always fit perfectly inside there. It will always hit all three sides. And that's the significance of the incenter, is it helps us create the incircle, basically a circle that fits directly inside of a triangle. So the concept here is that the incenter will always be equidistant from the sides of a triangle. So let me be clear about this. The circumcenter is always equidistant from the points. The incenter is always equidistant from the sides of the triangle. So that would be important if you're a city planner and you're wanting to create something. You got three major highways going through your town. If you want to create something that's the same distance from all three highways, you would need to know the incenter. Let's go ahead and do some notes. The three angle bisectors of a triangle are concurrent, and the point of concurrency is called the incenter. The incenter of a triangle is the center of the incircle. A circle that touches each side of the triangle at exactly 1 point. So that point is always going to be the same distance from all three sides. So here I would know that DH is the same distance as DF, is the same distance as DG. All three of those are the exact same. And as we pointed out in the dynamic example, the incenter is always inside the triangle. Now take a look at these two diagrams because you're going to see quite a few of these. It says AD and CD are angle bisectors. So that's enough to tell us that D is the incenter. So let's take a look at what it's asking us. It says the measure of angle DB or DCB. So if I start at D, go to C and B. So it's asking for that angle right there. Well, how in the world do I figure that out? Here's how. Because these are angle bisectors, I know that if this angle over here is 31, then I know that this angle over here is 31. So that whole angle, that big angle A, is 62 degrees. So now that I know that big angle A is 62, I know angle B is 76, I can add those together, subtract it from 180, and figure out how big angle C is. So 62 plus 76 is 138, leaving 42 degrees. So 42 degrees is big angle C, but I don't want big angle C. I want half of that, which would be 21 degrees. So kind of a long way of doing that, but it gets the job done. Let's take a look at the next thing, the distance from point D to line AB. So from point D to line AB, And we always measure the distance from a point to a line with a perpendicular line. Well, that's going to be the same distance as from point D to line AC, which is 21. And the distance from point D to point BC, that's also going to be 21. Okay? Hopefully that example made sense. Let's do the next one. Yeah, let's use blue. So it says XK and ZK are angle bisectors. So I know that this angle is the same as that angle. Find the measure of KZY and the distance from K to the other two sides. So we're going to do this the exact same way as the other example. If I want to know KZY, that's this angle right there. So the big angle X is 30 degrees. Angle Y is 43. So if I add those up, that's 73. Subtract that from 180, and I know that big angle Z is going to be 107. But I don't want the full angle Z, I want just half of it. So half of 107 is going to be 53.5. Last two things it wants to know, the distance from K to YZ. That's since K to XZ is 33, K to YZ is also 33. And the distance from K to XY, that's also going to be 33. So here's the deal. This may seem easy, might be intuitive. You might be like, okay, that makes sense. But keep in mind, we just did this, and then we did something similar with circumcenters. And then in a future lesson, we're going to talk about an orthocenter and a centroid. So each thing by itself isn't too bad, but you've got to keep it straight with 4 other things. So somehow get it organized in your mind. This is the incenter, it does this. This is the circumcenter, it does this. This is the orthocenter, it does this. This is the centroid, it does this. Okay? So just a future warning to keep yourself organized. Hopefully this lesson wasn't too bad. If you guys have any questions, please feel free to email me or talk to me in class, and I'll see you real soon. Have a good one.